Next we have logical operators. Okay, so let us start with the logical operators. Suppose if you have the two numbers x is equal to 5 and y is equal to 6. Now let us start with the logical AND operator. Suppose we check x is less than 5 and x is less than 10. So here you can see, is x is less than 5? Obviously x is not less than 5, it is less than or equal to 5. This condition, x is less than or equal to 5, means x is not exactly less than 5 but it is equal to 5. So this condition is nothing but false. Whereas x is less than 10, yes, it is true, but true and false results false. So logical operators are used to combine the conditional statements. So in the logical AND operator, the results will be true only if the value of two operands are true. So obviously the result is false. So if you check this in simple, let us use the first one, is x is less than 5, and check what happens. It is false. And in the next case, x is it less than 10? Yes, it is true. But when we use the two conditions, false and true, in the first case it is false and in the second case it is true. Result is false. Next we have logical OR operator. Is similar to x is, let us check, x is less than 5, once again with the same expression, or x is less than 10. So now x is less than 5, this condition is false, and x is less than 10, this condition is true. True or false is nothing but true. In logical operator, the result will be true if the either of the operands is true, means the value of the either of the operands is true. Okay. So the result is true. Next we have logical NOT operator. It simply reverses the result. So means it results false if the result is true, and it returns true if the result is false. So logical, not operator. Let us use this operator like this. Not x is less than 5. So we know that x is less than 5 is nothing but false. So opposite of the false is nothing but true. Similarly, if I check opposite of true by replacing x less than 10, we will get false. So opposite of true is nothing but false. So this is how the logical operators work in Python. These logical operators plays an important role in control flow statements, in if else, while, for loops, etc., nested ifs, and so on. So these all operators, arithmetic operators, plays an important role in mathematical calculations. Assignment operators also play an important role in mathematical calculations. Comparison operators play an important role comparing the different values in decision making as well as in control flow statements. Logical operators play an important role and they are necessary in control flow statements. Identity operators are used to check whether both the objects are same or not, and membership operators are used to check whether the particular value exists in a sequence or not. So we left with the Python identity operators and membership operators. Let us start with the Python identity operators. So here, as per the definition, Python identity operators returns true with respect to is operator. It results true or it returns true if both variables are the same object. Returns true both the operands or both the variables are the same object. And is not operator. Returns true if both variables are not the same object. So let us see this explanation in simple way. Okay, let's start with the is operator. Suppose if we have two variables, x is equal to 20 and y is equal to 20. First, let us check the address of each variable using the command id of x and the id of y. See here, you can see 219506317806 219506317806. Both are having the same address, means they are the same object. Let us check using the is condition. X is y is xy. Yes, they are the same object. If I print x is not y, then it results false because they are the same object. But this is not always true, because sometimes we assign the value of one variable to another variable, or we assign variable itself as a value to another variable. Say for example, if I represent g is equal to x, so look at here, g is equal to x. Now if I check the value of g, sorry, address of g using the id, so here I am getting the same address. Okay, means g is also referencing the same value. Okay, so they are nothing but the same objects, but these conditions or these operations are not valid always. In order to illustrate this, let us create a different variables with the different values. For example, x is equal to, here I will create a comma b, and y as again a, sorry, and again b, and I will also assign g is equal to x. Let us see what happens if I use x is g. So it results true because g is the same object as x. What if I print x is y? So what if I print x is y? The result is false. Here you can see earlier we got x is y true, but now we are getting false for this list of values. Why? Here because x is not the same object as y even if they have the same content, because x will be treated as a different list and y will be treated as a separate list. In order to check this, let us print the id of both the variables or lists. So here x is a list of elements a and b, y is a list of two elements a and b. So here you can see the difference. Earlier when we are using the integer value x is equal to 20 and y is equal to 20, we are getting the true value, but now it is not the case when with the different variables. Okay, even though these two lists have the same content, they do not reference to the same address. Okay, that's why x is not y. They are not the same object, means they do not reference the same address. So you can see it is at different address and it is at different address, so that's why they are not same. So we should do an hands-on work to check when the variables becomes the same object and when the variables won't become the same objects. Now if I check the last operation, that is x is equal to y. So if I use this command, we will get true because it checks only for the contents, not for the address. Equality symbol will check for the contents or the value of the variable. It doesn't look for the address, whereas is will look for the address. Okay, that's why when we have the list of values in x and the list of values in y of the same kind, then x also has the same values a and b and y also has the same elements a and b. That's why equality symbol will check whether the value of the left operand is equal to the value of the y operand, or is the values of the value of the left variable, is it equal to the value of the right variable. So obviously y also has the same variables as the x. But if you observe g is equal to x, means the values of g will be assigned to g. So hence g is the new variable. Even though g is a new variable, it refers to the same object x, because we are assigning x to the g. So this g refers to the same address. Hence, this statement x is z results true. If I check once again, is g is y, because both have the same elements ab in x and z, sorry, x and y. Let us check what happens. So obviously the result is false, because we have not assigned y to the variable g. We have assigned only x to the variable g. Hence the address of g refers to the address of x. That's why x is z becomes true. And address of x is different from the address of y, means id of x is different from id of y. Hence g is y results false, because g is actually referencing x. So in this case we are getting false. So we need to keep on working on these different types of exercises to get more knowledge on these identity operators. So finally we have an membership operators. Okay, first we have in operator. In membership operator. In membership operator results true or returns true if value is found in the sequence. So for example, here x is a list of values a and b. Okay. Let us check whether a in x means the element a, is it present in x. Yes, the result is true. So because x, a is found in the sequence x, because x is a list of two elements a and b. Let us check the unfound element, means undefined element inside the x. For example, we have not defined c. So if I check c in x, obviously we will get false, because we have not defined c in the list x, because x is a variable of type list. Okay, it has the elements a and b only. Next, not in. Suppose if I use the same variable c, and now not in instead of in, we will get true, because obviously c is not in x. There is no c, so that is the meaning of not in. Obviously c is not in x, hence it results true. So this is how you can work with the basic operators in Python. In order to see the applications of these basic operators, we have to refer to the sections control flow, decision making sections, and the advanced Python concepts, okay, like objects, etc. So before we move to the next lesson, do the practical work, do more and more hands-on work to get more knowledge, especially with respect to the membership operators, identity operators, bitwise operators, okay, assignment operators, and logical operators, and or not with respect to binary uh, bits, okay, and comparison operators. My sincere advice is, do not neglect any topic. The topic you neglect will appear in the interview or will make you to get tension or tensed, okay. You will be getting tension for what you neglect. Either it may be a small thing or it may be a big thing, whether it may be a simple concept or whether it may be a complex concept. So keep working on the practical exercises and keep working on with the hands-on practice. So see you in the next lesson.